Hello everyone and welcome to my channel Aptitude Club. Hope all of you are doing well. So today in this video we are going to discuss this question from the topic numbers, and this is from the area LCM. Now those of you who would have started their preparation for CAT 2025 and you would have read some topics in numbers would understand this is a very important question and a very difficult question in terms of logic. I'm not saying it is impossible to solve, but for people who are solving questions like this for the first time, it can be a little challenging, but a very beautiful question in terms of the applications of LCM. Okay, it really tests our understanding of how much into the depth we have gone in this topic, because LCM and HCF as topics are very simple. All of us know how to calculate HCF of two or more numbers, LCM of two or more numbers, but this is not asking us to calculate, rather it is asking us that how many possible pairs of numbers are there whose LCM is this much. LCM is given, we'll have to go in the reverse process. Okay, so if you are here for the first time in my channel, do explore the other videos that I have made on quantitative aptitude as well as logical reasoning and data interpretation. If you like my work, then do subscribe to Aptitude Club channel. Let's get started with today's video. Now before we get into solving this, let us try and understand what the question is asking, and I'll explain it in a way so that someone who is watching this or who is just starting their preparation, okay, from a very basic level, you will be able to understand. So it is saying find the number of ordered pairs. So let us try and understand what is the meaning of ordered pair. Now pair means two things. So let's say I'm taking A and B. So this is a pair. A and B is a pair. Now what is an ordered pair? Ordered pair means the order in which you are taking numbers. Okay, it can be A B or B A. So this is two ordered pairs. So that means from one number I can have a single pair. Let's say I have, let's say, A and B. So this is giving me a single pair. But then the order in which, like in which I'm taking them, A being the first one, B being the second one, or B being the first one and A being the second one. So this gives me two ordered pairs. Now I'll have to figure out how many such ordered pairs of natural numbers are there whose LCM is 3600. LCM is 3600. For example, I'll say what is the LCM of 2 and 2 and 900, for example. So if I have to calculate the LCM of 2 and 900, so the LCM here is 900. If I have to calculate the LCM of 3 and 900, again the LCM will be 900. You see the LCM is 900, but I'm getting two different pairs. 2 900 is a pair, 3 900 is another pair. Okay. So I'll have to see what are the different such pairs whose LCM is going to be 3600. And again I'll have to look for ordered pairs. Ordered pairs, the order in which I'm taking them. Okay. So 2 900 and 902 will be considered as two different pairs because the order in which we are taking. So I hope the question is clear. Even if you are not able to understand how do I get the approach and how do I figure out how to solve this one, how many such pairs, how do we get that? If you are not clear about that part or you are not able to formulate, it is absolutely okay. Let us first try and understand what this question is. Okay. So having said that, let's see what LCM is. I'll just briefly explain the concept of LCM. LCM, all of us know, is the least or the lowest common multiple. Now, what is a multiple? Multiples are always divisible by the number. So let's say I'm taking two simple numbers, 12 and 18. And to understand this concept, I'll use prime factorization. Prime factorization. So I'll prime factorize 12. So 2, 6 and 2, 3. And I'll also prime factorize 18. This is 2, 9 and 3, 3. So 12 is 2 square into 3 to the power 1. And 18 is 2 to the power 1 into 3 square. So we see 12 and 18, both of them have 2's and 3. The number of 2's and 3's is different, but both of them has 2's and. Now LCM is such a number which is going to be divisible by 12 and it is going to be divisible by 18. Now what kind of number will be divisible by both 12 and 18? So let's write 12 and 18 in the prime factorization form in the denominator. If I want a number to be divisible, when we solve for divisible we cancel out. So that means my numerator, that is the LCM, should also have 2's and 3's. I have to decide how many 2's and how many 3's. Now let's purely focus on the 12 part initially. If I want my LCM to be divisible by 12, how many 2's do I need? I should have at least two 2's so that I can cancel them and it will be divisible. I can take 2 to the power 3, 2 to the power 4, 2 to the power 5 and it is still divisible. But it will not be the lowest possible. Because I have to calculate LCM, I'll only take whatever is absolutely necessary. Anything more than that will be common multiple and not lowest common multiple. So absolutely necessary is 2 to the power 2. Beyond that, I'll not get the least possible value. So if I am having 2 to the power 2, then it is divisible by the 2 component of 12. 2 square divisible. If I look for the 18 side, 18 has only 2 to the power 1 and 2 to the power 2 is divisible by 2 to the power 1. That means in the LCM, if I am taking 2 to the power 2, 12 and 18 both are taken care of as far as the number of 2's are concerned. Similarly, let's look at number of 3's. Now in 12 I have only one 3, so I can take 3 to the power 1 in the LCM. But if you look at the side of 18, if you have LCM in 3 to the power 1 and 18 has 3 to the power 2, 3 to the power 1 is not divisible by 3 to the power. So for that I need to have 3 to the power 2. If I have 3 to the power 2 in the numerator, 3 to the power 1, 3 to the power 2, both of them are divisible in the denominator. And this is the least possible value. Hence I can say LCM is 2 square into 3 square, that is 30. Now this is nothing very difficult, okay? And all of us know, and most of you can calculate the LCM of 12 and 18. I'm just explaining the rationale behind this approach, okay? Because even if it's a very small example, the understanding is the same for a bigger question. You will see how this is used for this particular question. Now if I try and attribute, suppose I'll write LCM of 2 to the power 1 into 3 square and 2 to the power 2 into 3 to the power 1 is 36, which is 2 square into 3. This is 18, this is 12 and this is 36. If we try and attribute, why is 2 to the power 2 present in the LCM? Because of 12. Why is 3 to the power 2 present in the LCM? Because of 18. This is attribution. And trying to understand why is there a term present in the LCM. There should be a reason if 2 square is there or 3 square is there. Having understood this part, let us try and go to the question now. In the question, let the ordered pair be AB. Let us say the ordered pair is AB. I'll have to figure out how many possible values of A and B are there. And for this ordered pair, the LCM is given as 3600. Now let us try and prime factorize 3600. 3600, I can write this as 36 into 100. 36 is 2 square into 3 square and 100 is 2 square into 5 square. So I'm getting 2 to the power 4 into 3 to the power 2 to 5 to the power 2. This is the LCM. Now I'll have to go for individual attributes. Now just like in case of 36, 36 has 2 and 3 and we saw 18, 12 both had 2. Similarly in LCM also, A should have a certain power of 2, a certain power of 3 and a certain power of 5. Same goes with B. B should have a certain power of 2, a certain power of 3 and a certain power of 5. I'll have to figure out individually now. Let us focus only on the 2 part now. We'll replicate the same logic for 3 and 5. So distribution of 2. Let me look at this. Distribution of 2. Because LCM has 2 to the power 4, so the highest power that 2 can have, I can have a 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3, 2 to the power 4. Similarly, because again LCM has 2 to the power 4, so highest power of 2 in B can go till 2 to the power 4, the lowest can be 2 to the power 0. Now comes the important part. Because LCM definitely has 2 to the power 4, definitely one amongst A or B, it can be both, but either one of them definitely has 2 to the power 4. At least one of them has to have a 2 to the power 4. Why else LCM will have 2 to the power 4? So either A has 2 to the power 4 and B has some other power of 2, or B has 2 to the power 4 and A has some other power of 2, or maybe both of them have 2. That is also possible. Based on that logic, how many such pairs can I make? So let's say A has 2 to the power 4, then there are 5 possible pairs, because 2 to the power 4 can be paired with 2 to the power 0, 2 to the power 1, 2 to the power 2, 5 possible variants in B, so 5 pairs. Similarly, if B has 2 to the power 4, A has 5 possible powers now. But I'll subtract a 1 because there is a repeat counting. You see, A equal to 2 to the power 4 and B equal to 2 to the power 4. This was counted twice. This was counted twice. Because first time when I was pairing A taking 2 to the power 4, so A 2 to the power 4, B 2 to the power 4 was counted once. Next, when I took B as 2 to the power 4, again I counted A 2 to the power 4 once again. So that is, I'll subtract once. So 5 plus 5 minus 1. I can distribute the power of 2 in 9 ways. In 9 ways. Okay. So this is how 2's can be distributed. Let's look at 3's. Distribution of same logic. If I try and distribute 3's, distribution of 3's. Now because LCM has 3 to the power 2, so A can have 3 to the power 0, 3 to the power 1 and 3 to the power 2. B can also have a 3 to the power 0, 3 to the power 1 and 3 to the power 2. But LCM definitely has 3 to the power 2. That means at least one of A and B should definitely have 3 to the power 2. So if A is 3 to the power 2, I'll have 3 pairs. And if B is 3 to the power 2, again I'll have 3 pairs. But again 3 to the power 2, 3 to the power 2 is counted twice. So 3 plus 3 minus 1. I can pair them in 5%. And if you go to distribution of 5's, again the same process. 5 to the power 2 was there in LCM, so 5 to the power 0, 5 to the power 1 and 5 to the power 2 are 3 different powers. In B also I'll have the same thing. And when A is 5 to the power 2, you will again have 3 possible powers in B, and when B is 5 to the power 2, you will have 3 possible powers in A. So 3 plus 3 minus 1, because 5 to the power 2 is counted twice now. 5 ways. So total ordered pairs if I am taking, so 2 was distributed in 9 ways, 3 is distributed in 5 ways, and 5 is distributed in 5 ways. So 45 into 5, 225 should be matched. Okay. So the answer to this question will be option. Hope all of you understood the normal process of solving this. Now I'll tell you a method where you can solve this question in less than 10 seconds. Okay. How do I solve this in less than 10 seconds? For that, I'll try and develop a shortcut. Now that you have a proper clarity of what this question was all about, and we have already arrived at a solution also, let us try and understand the shortcut. So LCM was 3600, which is 2 to the power 4 into 3 to the power 2 into 5 to the power 2. And I was supposed to distribute this between two numbers A and B. Okay. So let us purely look at the LCM. So 2 to the power 4 when I am taking here. So 2 to the power 4, 2 to the power 0, 2 to the power 1, 2 to the power 2, 2 to the power 3 and 2 to the power 4. So here A can have 5 possibilities and B can have 5 possibilities. So total I will have 25 combinations. I'm not bothered about LCM. I'm just seeing how many combinations of the powers that I can make. 2 to the power 0 till 2 to the power 4. So A can take any of these 5 powers. B can take any of these 5 powers. And I'll definitely have 25 combinations. What? Not for all these combinations the LCM will be 2 to the power 4. Because, for example, I'll have a combination where A is 2 to the power 0 and the B is 2 to the power 2. So why will the LCM have 2 to the power 4? So LCM, if it is having 2 to the power 4, so as we have discussed, A and B should definitely have 2 to the power 4, at least one of them. So the combinations in which none of them have 2 to the power 4, I'll try and subtract them. Because if in a combination none of them have a 2 to the power 4, why will the LCM have 2 to the power? So let's see in how many combinations I don't have 2 to the power 4. So the number of combinations I can make using 2 to the power 0, 1, 2, 3. So that combinations I'll subtract. Because if I'm including 2 to the power 4, then at least one of them has a 2 to the power 4. So the combinations taking the first 4 powers will be removed. So I have 4 cases for A and 4 possible values for B. So 4 into 4, 16 combinations are possible which don't have 2 to the power 4. Hence, 25 minus 16 in 9 combinations definitely have 2 to the power 4. So 9 combinations we are having definitely 2 to the power 4. And we need that because our LCM has 2 to the power 4. So now 9 in the first process we calculate as 5 plus 5 minus 1. Okay, in the normal way. But here this 9 can be calculated as 5 square minus 4 square. What is 5? Basically whatever power I have here. Let's say this power I'll take it as P. This I can write it as P plus 1 square minus P square. So whatever power you have, add a 1, then square it minus P square. So same logic if I'm taking for 3 to the power 2. Let's try and understand the same thing for 3 to the power 2. Okay. Again LCM is 2 to the power 4 into 3 to the power 2 into 5 to the power 2. Now in 3 to the power 2 I have 3 to the power 0, 3 to the power 1 and 3 to the power 2. So there are 3 possible values for A and 3 possible values for B. So 3 into 3, 9 combinations are possible. But not all combinations again have a 3 to the power 2. So 3 to the power 0 and 3 to the power 1. How many combinations can I make here? 2 into 2, 4 combinations. Don't have 3 to the power 2. So you subtract 9 minus 4. 5 combinations definitely have 3 to the power 2. How do I get this 5 again? Is 9 minus 4, which is 3 square minus 2 square. And again, let's assign another value here. If q is equal to 2, I get the same pattern again. Power plus 1 square minus q square. So that gives us the logic that if I have the LCM with me like this, I have generalized this. If I have the LCM with me like this, any number in the form a to the power p into b to the power q into c to the power r. This is the prime factorization form of the LCM. Prime factorization form. So if LCM is in this form, so the number of ordered pairs of natural numbers can be directly given by this form. For an example, we'll take this particular question that we are solving. LCM was 3600, which is 2 to the power 4 into 3 to the power 2 into 5 to the power 2. Now you see this is in this particular form. Focus on the powers. So what is P? P is equal to 4, Q is equal to 2, R is equal to 2. So just put them in the formula. P plus 1 whole square. So 4 plus 1 whole square, 5 square minus 4 square into Q plus 1 whole square. Q is 2, so 3 square minus 2 square into R is 2. Again, R plus 1 whole square is 3 square minus 2. So 5 square minus 4 square is 9, 3 square minus 2 square is 5, 3 square minus 5. So I get 225 directly. To know this formula, you can just answer this in 10 seconds. And this is a very good question in LCM and considered to be one of the difficult ones. Very conceptual, and I have explained you the normal process, but this is the shortcut I am giving you. You can solve it in less than 10 seconds if you follow this approach. But not like it's not the end yet, because we can like increase the difficulty of this question by taking it to number of ordered triplets. Ordered pairs was like this, A, B. But ordered triplets is like A, B and C. I bring in another number also. So let's say I'll have to calculate the same thing. How many such ordered triplets of natural numbers are there whose LCM is 3600? So not two numbers now. Three numbers I have to select such that their LCM will be 36. So I can go by the same logic. A, B, C and distribute that way. But then we can just tweak the formula a little bit. So if it is ordered pair, so that means the power will be 2. You see, I'm taking square every time. P plus 1 square, Q plus 1 square, P square, Q square. If it is ordered triplet, then the power is 3. So exact same structure, just the power will become 3. P plus 1 cube, P cube, Q plus 1 cube minus Q cube, R plus 1 cube minus R cube. And similarly ordered quadruplets also. A, B, C, D, 4 numbers. 4 such numbers whose LCM will be this much. Again you will get a same pattern. In quadruplets you will have the power as 4. Same formula, just tweak the power. In case of pair you subtract the squares. In case of triplets subtract the cubes. In case of quadruplets take the fourth power answer. Very easy. These questions, if you go by the normal process, will take a lot of time. People would have not solved this and will try to crack this question, they will also have to invest a lot of time in the understanding part. But then this is a very good question to enhance our understanding of LCM. Okay, and if you solve such questions, your mental ability to process the applications of like LCM questions will significantly go up. Okay, while practicing we should not expect, okay, this is a question I've solved, this should come in exam. Doesn't matter if it comes or not, it is helping us enhance our ability to think about a question. And all shortcuts are derived from the normal process only. And to appreciate a shortcut, remember it, and to be actually able to apply it in the exam, I should first understand the normal process, the logic, the derivation of the shortcut. Only then it will be helpful for me. Just knowing the formula is not enough. So I also tried to derive the shortcut for you people. Hope you understood this. Now let me calculate ordered triplet and ordered quadruplet, although it was not part of the question. But let's calculate just for our understanding. So same LCM is 3600. How many ordered triplets are possible? So it is 5 cube minus 4 cube now into 3 cube minus 2 cube into 3 cube minus 2. So 5 cube minus 4 cube. 5 cube is 125 minus 4 cube is 64. It is 61. And 3 cube minus 2 cube is 27 minus 8 into 19 into. So whatever answer, you can just multiply and calculate. Similarly, ordered quadruplets if the question is asking. So 5 to the power 4 minus 4 to the power 4 into 3 to the power 4 minus 2 to the power 4 to 3 to the power 4 minus, and again we can calculate. Very easy and very simple. If I have understood the shortcut and its derivation, no need to be confused. Look at what the question is asking: pair power 2, triplet power 3, quadruplet power 4. Maintain the same structure. So I have attached 3 questions for you people, and options are also given here. So try and answer these questions, okay, based on the formulas that I have given. So I'll just calculate this. Number of ordered pairs of natural numbers whose LCM is 400. So LCM 400 means it is 4 times 100, so 2 square, and 100 is 2 square into 5 square. I have 2 to the power 4 into 5 square. So P becomes 4 and Q becomes 2. So P plus 1, 4 plus 1, 5 square minus 4 square into 3 square minus 2. 5 square minus 4 square into 3 square minus 2. Again I'll have 9 into 5, 45. You can answer it in less than 10. So accordingly try these two questions. Okay, options I'm not sure. They look similar. I think I have not edited question 2 and 3 options. But no worries. Look at the questions and try and solve, and let me know your answers in the comment section for question number 2 and 3. So that is it from my end for this video. Hope you guys like this video. So do subscribe to my channel if you found this video useful for you, and watch out for the other videos that I've made, the quant booster series as well as LRDI experts. We'll see you again in another video. Till then, keep solving and have a nice day. Bye bye.